In the previous video, we talked about standard form and how it's useful for expressing very large numbers or very small numbers. When some of you are going to be doing physics or chemistry or combined science, you're going to see that in experiments, there are going to be very small difference or very large difference. Very small difference happens in vibrations, and very large difference happens when you're measuring the movement of planets. So you need to reduce those numbers into comparable form or forms that we can comprehend. That's where standard form comes in. But today we are going to talk about number bases. So the normal base that we are used to is base 10, where we count numbers from 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we start to repeat again. We start to repeat 1, 0. This is 1 and 0. Then we repeat again 1, 2, 1, 1. Then we repeat again 1, 2, 1, 3, 1, 4. So this is base 10. Right, the topic, number bases. Number bases. So we're used to counting on base 10. So whenever you see a number, maybe 375, there is a base 10. There is a base 10. If it's base 10, there is no value for 10, we return to 1, 0, 1, 1, 1, 2, 1, 3. So there is no number greater than 10 in base 10. So we are going to learn about other bases, base 1, base 2, base 3. So for example, if you are told to count in base 5, you are going to have 0, 1, 2, 3, 4. Then after this, you will return. There is no 5 in base 5. So you are going to have 10, 11, 12, 13, 14. Then there is no 15. Any number greater than 5, you are going to remove 10. Then you are going to have 20, 21, 22, 23, 24. That's how you count in base 5. So if you are given a number in base 5 and you want to convert it back to base 10, that is what we are going to learn today. How to convert a number in base 5 so that it can return to base 10. So first of all, we have a number 3, 4, 2, which is in base 5. And you need to return it to base 10. You need to convert this number to base 10. So what you do here, you say this is 5 to the power 0, this is 5 to the power 1, this is 5 to the power 2. So to convert to base 10, you're going to say 3, this 3, multiplied by 5 to the power 2, plus, you're now going to add this one, 4, this 4 right here, multiplied by 5 to the power 1, plus this 2 here, 2 multiplied by 5 to the power 0. So you've converted this figure back to base 10. So 5 to the power 2, that's 25. 25 times 3, that's 75. Plus 5 to the power 1, that's 5. 5 times 4, that's 20. Plus 5 to the power 0, that's 1. So we add 2 here. So 75 plus 20, that's 95 plus 2. So 95 plus 2, it's going to be 97. So this one is in base 10. So if you are given a number in any base and you are asked to return it to base 10, you take the base and you multiply it by power of the respective position. So the first position is power 0, this one is power 1, this one is power 2. So that after that, you do this operation and you return a number to base 10. So how do you return a number from base 10 into any other base? How do you turn a number in base 10 into any other base? For example, if you have a number 50 in base 10 and you need to convert it to, for example, base 5, you need to convert it to base 5. So what you do here is you put your 50 here, you put your 50 here, then you divide by the base. You divide by the base. You divide by the base here, you divide by 5. So 5 into 50, that's how much? 5 into 50, that's 10. Remainder 0. So 5 into 10, that's 5 into 10, that's 2. Remainder 0. 5 into 10 is 2, remainder 0. Then 5 into 2, that's 0, remainder 2. So when you are reading this value, you take from the bottom to the top. So 50 in base 10 converted to base 5, it's going to be 200 in base 5. So that's how you convert a number from base 10 to any other base. So we are going to meet when we are going to talk about cells.